our channel. So in today's session, we'll discuss about one more searching algorithm, that is a binary search. Binary search. So in our previous session, we have discussed about the linear search, and we have found that a drawback if the search element is at the 100th position. So we need to iterate from the first element towards the last element, because just we are comparing each and every element. So the time complexity will be more. So if we take more time, if there are more number of elements in the list. So for example, if the list or a sequence as having only a limited number, that means 10 elements or some 5 elements, then it would be very easy. So it requires only 4 comparisons or 5 comparisons. But if it is 1000 elements, so it requires some 999 comparisons, and at the 1000 comparison, the search will be successful. So in order to avoid that one, so we will go with the binary search. So the first advantage of using this binary search is we can reduce search space. So you need not, even though the search element is successful at the last position, so we need not perform all the iterations, right? So we can reduce the search space. And the next, one condition should be satisfied before applying this binary search, that elements should be in a sorted order. Elements of a sequence should be in sorted order. This is very important. Sorted order. So unless the elements are in sorted order, we can't perform this binary search, because based upon this sorted order, if the elements are in the sorted order, then only we can reduce the search space, and by iterating that one, so we can find the search element. Right. Next. So how it will be done? For example, we are having a sequence, list is equal to some 10, 20, 30, 40, 50. So I will take only 5 elements. And I am writing the index values here 0, 1, 2, 3 and 4. Okay, so these are the index values. So this row is nothing but index, right? So first we have to find the low value and the high value. That means, what is the low value? The starting index with the low value. What is the high value? The index of the last position. Okay, so I take low as 0 because 0 is the starting index, and high value as 4. High value as 4, right? So 4, this we can call it as the length of L minus 1. That is nothing but 4. So if we are having some 10 elements, the high value will be 9. If the list is having some 50 elements, the high will be, so length of L, that means the 50 minus 1, that is the 49. So 49 is the index of the last position. So first we need to find out the low and high value. So then we have to calculate the middle element. What is the middle element? So how we can get the middle element? Middle element is equal to, so low plus high, the low index plus high index 2. So here I am using the floor division operation. So if you use the division operation, we may get the float value, right? So for example, so 9 divided by 2. 9 divided by 2. So 9 divided by 2 means, so we will get here some 4.5. So if it is a floor division, 9 floor division of 2, so it will be 4. So that's why we are using the floor division, particularly in Python. So in other languages we don't have this option. So we'll get only if both the numerator and denominator are integers, we'll get the result in an integer. So directly we can give this one. But here that's not case. In Python 3, so even though the numerator and denominator both are integers, the result will be the accurate. So that's why we are going with the floor division. So here by calculating the middle value, so we will get the middle index. All these are the indexes, right? So low is index, high is index, and mid is index. So what we had a mid value. Okay, we had a mid value. So what we can do, see, for example, the search key is some 20. Search key is some 20. And here I write the second case, search key is some 40. Search key is some 40. Two cases. So one thing, so here we can compare the mid value. So how can we get the middle element, not the index, middle element? So L of mid will give the element. L of mid will give the element, not the index, right? So if this is equal to the search value, if this is equal to the search value, so this is case 1. Case 1. If this is equal to the search value, so obviously search will be found and we can say that the search element is available in the position mid. Mid is nothing but the index value. Case 2. That means if it doesn't match, so three possibilities. If you want to compare two numbers, three possibilities. One is both are equal. Second one, first number is less than the second number. Third one, first number is greater than second number. So we need to find out all these cases. For example, here you can see if this is wrong, if this is failed, so L of mid is greater than yes. That's the case 2. And case 3, L of mid less than yes. So three conditions. So if it is equal, automatically we can stop the procedure. Okay, we can stop the procedure. So you can observe here, we are having a 5 element. If we are calculating the middle element and we are searching, so even though the element is in the third position, for example, so in this case, let it be S is equal to 30. S is equal to 30. What happens here? Mid is equal to, so low 0 plus 4 by 2. 0 plus 4 by 2, which is nothing but 2. So L of 2 is equal to 30. So L of 2 is nothing but 30. So this is successful. So that implies if even though the element is at the third position, we are not comparing the previous elements, right? So which happens in the linear search. So if the element is in the third position, we have to compare the first two elements. Then only we are comparing the third element. But here is not that case, right? Even though the element is in the middle position, that means the third position. So we are directly checking the third position by finding the mid value. So now the case is if S is equal to 20. If S is equal to 20. So what happens here? So this implies, see, L of 2 is equal to yes. That implies, so 30 is equal to 20. So we are taking 20 here. So this fails. So that must be either second case or third case. That may be either second case or third case. So let us check with the second case. L of 2 is greater than yes. That means 30 greater than 20. 30 greater than 20. Yes, true. This is true. This condition is true here. So see, 30 is greater than search element. The middle element is greater than the search element. So here what we have done, elements of sequence should be in a sorted order. If the search element, if the middle element is greater than search element, middle element is greater than search element, obviously the search element should be on the left hand side of the mid element, right? So for example, you can observe here, this is the middle element. You are saying that middle element is greater than the search element. Obviously, it is in a sorted order. The element should be on the left hand side. So we don't know the element. Obviously, the element will be on the left hand side. So it may be available or it may not be available, but it should be in left hand side. So what we have to do, again we need to change the low value and mid value. So the search space is reduced to the left hand side. So here the low value will be remain same, 0, and the high value will now become, we have already verified with the middle element, so this one. So the high value will be mid minus 1. So that means the search space is reduced in this space. Okay. So in the first iteration, the search space is around 5 elements. In the second iteration, so the search space will be reduced to only 2 elements. So just careful. So here 30 is greater than 20. 30 is the middle element. 20 is the search element. So if the middle element is greater than the search element, obviously the search element will be available on the left hand side of the middle element. Now we will go with the second case. Okay. So after that I'll explain this problem. Second case. So if S is 40 now, if S is 40 and L of mid is equal to 40. So L of mid is 30 is equal to 40. So this is false. It will move to the second condition. So that is L of mid greater than S. That means 30 greater than 40. Again it is false, that is not greater than 40. Again it will go with the third one, L of mid less than S. That means, so 30 less than 40. So that implies the middle element is less than search element. Middle element is less than search element. So that implies the search element will be on right hand side of the middle element, right? So simply we can change the, similar to this one, change the low and high. So the low value will be, okay, mid plus 1, because already we have compared with the mid. So low value will be mid plus 1 and high value will be again the length of L minus 1, that is the 4. That's it. Length of L minus 1. Okay. So we need to repeat this process, again find out the mid and again calculate these 4 conditions, these 3 conditions. Okay, so here we need to change the low value, so high value. So high value is equal to the mid minus 1, and in this case we need to change the low value. Low is equal to mid plus 1 and high is equal to some length minus 1. Okay, so this is the cases we need to do. And now we will see an example, right? So let us take an example of this one and we'll calculate. See, let us take search value as some 10. Okay, search value as 10. So let us consider the mid value. So mid element is equal to 0 plus 4 floor division of 2. So the mid value is 2. So we need to compare L of mid is equal to yes. So what happens here? L of mid means L of 2 is equal to yes means 10. S means 10. So L of 2 means 20. 20 is equal to 10, which is false. So we need to check for second case. So what is the second case? L of mid less than yes. So that means L of 2 less than 10. So 20 less than 10. Sorry, L of 2. Yes, 30. It's 30, not 20. Here is also 30. Okay, 30 is less than 10. No. So go with the next one. L of mid. Only 3 conditions, greater than yes. Only 3 conditions. One is equal to, one is less than, one is greater than. So L of 2 greater than yes. So 30 greater than 10. 30 greater than 10. Yes, correct. That implies the search element, the middle element is greater than 10. So the search space will be less. Right? So here we will be having low is equal to 0 and high is equal to mid minus 1. Mid minus 1. So because already we have compared the mid element, right? So here we have compared mid element. So we have to reduce the search space from 0 to mid minus 1. So again calculate the mid value. So mid value is equal to 0 plus high. Mid minus 1 means mid is 2, 2 minus 1, 1 floor division of 2. So we will get a mid value as a 0. So L of mid, again compare the three conditions. L of mid is equal to L. What is L of mid? 0. L of 0 is equal to 10. L of 0 is 10. So 10 is equal to 10. So true, automatically the search is found. The search element is found. Right? So in this way, we have to iterate the same step. So we need to find the mid value for all the reduced search spaces. So keep on iterating. So we are reducing the search space. Right? So if there are n, so in the first iteration we will reduce the space to n by 2. In the second iteration we will reduce the space by n by 4, etc. and finally, if you get this one, so we'll do that. Otherwise, so the search will be not found. Right? So hope you understood. So if low is greater than high, simply that implies the element is not there. Okay. So low should be always less than high. The low value should be always less than high. That we know that. Right? So index values we are starting from low and high is the last index. So if the calculation, by this calculation, if any case, if low is greater than high, that implies, so the element is not available in the list, available in the sequence. So we need to repeat this process, finding out the mid and changing the reducing the search space until the low greater than high. Right? So hope you understood this one. So we'll move on to the interpreter. I'll execute the program and I'll show you. So if still anyone having any doubts, so that doubts will be cleared. So let's move on to the computer. Hello friends. So just now we have seen the theoretical part of binary search. So we'll execute the program. So this can be done in two ways, iterative and recursive. So we'll see the iterative method. So first I'll give the sequence. So list, and we need to take the input. So how many number of elements we need to insert. So input of enter number of elements. To be inserted, and after that we need to read all the elements. So I'll go with the loop iterative statement, I in range of n, read all the elements. So I'll use the append function. So append, and here I'll go with the int input. Right? So before that I'll display one message to enter the element. So print enter n elements. Okay, by using this one, it will display the message and you will prompt for the number of elements. After that, the one condition we have to check before applying the binary searches, it should be in sorted order. So I will go with the function called l.sort, so which will sort all the elements. So sort function is available in the list, right? So once it was done, so we need to find out all the remaining. So that means we need to reduce the search space by finding the middle element. So low it will be always 0 and high will be always the length of L minus 1, and always initially the mid value will be 0, and we need to iterate this thing, means finding the mid value and everything. So until the low value less than or equal to high. That means whenever the low greater than high, the iteration will stop. Right? So we know that the low value should always be less than high or equal to. So if it is greater than, automatically we have to stop the process. So we need to find out the mid value. Mid is equal to low plus high modulo, floor division of 2. And after finding out of mid, we need to check for the conditions. If L of mid oh, we need to take the element, right? So some s is equal to int of input enter search element. So we need to read the search element. So L of mid is equal to yes. Sorry, yes. So simply we can say S is found at position mid plus 1. So mid will give the index value, mid plus 1 gives the position, as we have discussed in our theoretical session. So if the position is 3, the index value will be 2, and you can break the statement. Okay, you can break. You did not go for the next iterations. And if it is not successful, that implies again we need to check one more condition. L if mid is greater than yes. So what we have to change? So that means the middle element is greater than the search element. So the search element will be available on the left hand side of the middle element. That means we need to change the high value. So high will be mid minus 1. And in the rest of the case, that means if two cases are false, that means middle is equal to yes and the middle is greater than yes, both the cases are false. That implies nothing but the middle element is less than the search element. Middle element will be the middle element is the less than search element. That means the search element will be available on the right hand side. So we need to change the low value with mid plus 1. So already we have verified with the middle element, we need to change the middle. So else, that means if none of the condition is executed, automatically it will come under the else part. So here you can give yes is not found. That's all. Very simple. We need to check the three conditions. We have to find the middle value and we have to check the three conditions. Execute. So I will go with the 4 elements. I'll give in a random order. So 40, 10 and 30 and 20. So these are not in a sorted order, right? So here I am giving some 20. So you can get 20 is found at position 2. So before going to that, we can print the elements after sorting. So print after sorting, print yes. So I'll go with the 4 again 50, 30, 10, 20. So after sorting 10, 20, 30, 50, and if you go with the 50, so 50 is found at position 4. Very simple. And if I can execute, so 4 elements, so 30, 20, 40, 10, and if you are searching for 50, 50 will be not found. So this is how we can find the binary search, right? Hope you understood. And if you are using the recursion, right? So this we have implemented by using iterations, and if you want to execute the thing by using iterations, okay, simply you can change the code, simple code. So before taking this one, after finding all the things, just call the function. So find out the mid value. See, remove, find out the middle value here. So low plus high 2 and open braces, and yes. Now you can call the function. So binary search of, pass the list, low value, high value, mid value, and the search element. So we need to write down the functions here. So we need to write down the function here. So I'll write down the function here, right? So all the user defined functions should be written in the beginning itself. So def binary search of L, low, high, mid, and yes, 4 parameters. So here we need to write down the code. So whatever the code we have written, the same thing. So low less than or equal to high. Find out the mid. Mid is equal to, so again low plus high 2. Okay, and if L of mid is equal to yes, so simply you can print yes is found at position same, which is a mid plus 1, and yes, and next elif L of mid greater than yes search element, key means search element, and we need to change the high value. So simply you can again call the function. So search. So what is the thing? First L, low, and high will be changed to mid minus 1, and middle element and yes. So we have changed the high value to mid minus 1. So now the search space will be from low to mid minus 1. And the rest of the case we need to change. That means if the middle element is greater than search element, we need to change the low value. So again call the binary, the recursive function search L mid plus 1 to high with a mid and yes, right? And in this else case, simply print yes is not found. That's it. Execute 4 elements. So I'll give 40, 10, 30, 20. So after sorting this one, so I'll go with the 30. So 30 is found at position 3. So this is by using the recursion. So instead of writing the code, we are just calling the function itself. So here itself we are changing the high value, and here we are changing the low value. So once again, so execute 4 elements, 20, 30, 10, 50, and I am searching for 40. So 40 element is not found. Right? So hope you understood. This is the execution by using an iterative process, and this is the execution by using the recursive process. So hope you understood this one, and if you are having any doubts regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.